In this video, I will show you how to find the exact value of various trig functions at special angles such as these. Now, throughout this lesson, I'm going to be assuming that you have memorized the values on this chart. So if you have not memorized the values on this chart, pause the video and memorize them right now. Okay, so problem number 4. We have the sine of negative 5 pi over 6. I see that the denominator is 6. So that tells me that the reference angle is pi over 6. So I'm going to draw you this sketch of a bunch of pi over 6s. However, I want you to get so good at this that you don't have to draw the sketch. So I'm showing you the picture for instructional purposes. But once you get good at this, I'm expecting that you will be able to picture this in your mind and not have to draw it. Alright? Because drawing these drawings every time will take too long. Okay, so negative 5 pi over 6 would be like this. Alright, this would be negative 1, 2, 3, 4, 5. So this would be the terminal side of negative 5 pi over 6. Now, because of the chart, we know that the sine of pi over 6 is 1/2. So the sine of negative 5 pi over 6 is also going to be 1/2, except maybe it needs a negative sign, depending on the quadrant. So remember, every point on the unit circle is of the form cosine of the angle, comma, sine of the angle. The point of this is that you need to understand that sine is a y value and cosine is an x value. So in this third quadrant, are y values positive or negative? Yeah, y values are negative below the x-axis. So for that reason, we know that it's going to be negative 1/2. Okay, look at number 5. The reference angle is pi over 3. So we're going to start by asking ourselves, what is the tangent of pi over 3? Alright, and again, we've memorized that. The tangent of pi over 3 is radical 3. Alright, that means the tangent of 5 pi over 3 is either going to be radical 3 or negative radical 3. To decide whether it's negative or not, I just need to understand what quadrant I'm in. Okay, so since the reference angle is pi over 3, I'm going to draw a bunch of pi over 3's. Okay, so 5 pi over 3 would be like this. Well, if I went all the way around, that would be 6 pi over 3. So this is 5 pi over 3. The terminal side would be right here. This is the fourth quadrant. Okay, now tangent is positive in the first quadrant and the third quadrant, and tangent is negative in the second quadrant and the fourth quadrant. Alright, memorize that. So tangent is negative here in the fourth quadrant. So therefore, we're going to choose negative radical 3 for the answer. Okay, look at number 6. Cotangent. So first of all, cotangent is the reciprocal of tangent. So what we really will wind up doing is we'll find the tangent of 9 pi over 4. And then whatever the answer to that is, we'll take the reciprocal of it. We'll turn it upside down, and that'll give us the cotangent. Alright, well, if I want to know the tangent of 9 pi over 4, first I'm going to consider the reference angle. What is the tangent of pi over 4? Now you should have memorized that the tangent of pi over 4 is 1. Alright, so since the tangent of pi over 4 is 1, the tangent of 9 pi over 4 is either going to be 1 or negative 1. And that just depends on the quadrant. Okay, so here's a little sketch of pi over 4s. Alright, and I encourage you to picture this in your mind instead of drawing it every time. Okay, so if I went all the way around, that would be 8 pi over 4. So if I went 9 pi over 4, that would be one more. That would put me in the first quadrant. And in the first quadrant, tangent is positive. So that means this will be positive 1. Now the cotangent should be the reciprocal of this. Alright, but the reciprocal of 1 is still 1. Alright, so the cotangent is 1. Alright, how about number 7? Cosecant is the reciprocal of the sine function. So first I'm going to ask myself, what is the sine of pi over 2? And then whatever I get for this, I will take the reciprocal of it. Now this is not one of my special angles. It's not one of these. But what it is a quadrantal angle. Alright, this is an angle that falls right on one of my axes. So pi over 2, bam, is right here. That's pi over 2. Okay, now the coordinates of these points on the quadrantal angles are like 1, 0, and this is 0, 1, negative 1, 0, and 0, negative 1. Now remember what I told you before. Sine is a y value on the unit circle. So you should be focusing your eyes right here. Boom. So the sine of pi over 2 is 1. So the cosecant of pi over 2 should be the reciprocal of that, which is also 1. Look at number 8. Okay, cosine of 5 pi over 6. Well, let's start by asking ourselves, what is the cosine of the reference angle pi over 6? And we have memorized that the cosine of pi over 6 is radical 3 over 2. That means the cosine of 5 pi over 6 is either radical 3 over 2 or negative radical 3 over 2. All we have to do is look at what quadrant it's in. Now, by now, I'm hoping that you do not need to draw a picture like this. I'm hoping you can just visualize it in your mind. But I'm going to draw it for instructional purposes. Okay, so 5 pi over 6 would land right here. Okay, so that is in the second quadrant. Cosine is an x value, and x values are negative to the left of the y-axis. So that means this is going to be negative radical 3 over 2 because of the quadrant that it's in. Alright, cosine of 9 pi. Well, okay, pi is half of this circle. So this would be like 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi, 9 pi. Alright, all the odd ones are going to be over here. So the coordinates of this point are negative 1, 0. Cosine is an x value on the unit circle. So negative 1. So that's it. The cosine of 9 pi is simply negative 1. Okay, sine of 2 pi over 3. Well, let's start by asking ourselves, what's the sine of pi over 3? Alright, we've memorized that the sine of pi over 3 is radical 3 over 2. So that's going to be radical 3 over 2. Now the sine of 2 pi over 3 is either going to be radical 3 over 2 or negative radical 3 over 2. So we just need to know what quadrant we're talking about. So the reference angle is pi over 3, so here are a bunch of pi over 3s. 2 pi over 3 would be right here, and that is in the second quadrant. Sine is a y value, and y values are positive above the x-axis. So the answer is going to be positive radical 3 over 2. Okay, let's do a few more. Tangent of 5 pi over 2. Pi over 2, again, is a quadrantal angle. Okay, like this is pi over 2 right here. So if I went all the way around, that would be 4 pi over 2. So 5 pi over 2 would be one more. So that's going to be right there. The coordinates of this point are 0, 1. Tangent is sine over cosine. Tangent is y over x. Okay, so this would be like 1 over 0, but that is undefined. So that's the answer to number 11. Alright, number 12. Cotangent of 7 pi over 3. Well, let's first ask ourselves, what is the tangent of 7 pi over 3? Because cotangent is just the reciprocal of tangent. So what is the tangent of 7 pi over 3? Whatever I get for the answer, I'm just going to take the reciprocal of it. So tangent of 7 pi over 3. Now, first I'm going to ask myself, what is the tangent of pi over 3, the reference angle? Because these are very closely related. Now this is something that I have memorized. The tangent of pi over 3 is radical 3. Okay, so the tangent of 7 pi over 3 will either be radical 3 or negative radical 3. I just need to know what quadrant I'm in. So since the reference angle is pi over 3, I'm going to draw a diagram of pi over 3s. If I went all the way around, that would be 6 pi over 3. So 7 pi over 3 is one more. So that's the first quadrant, so tangent is positive there. So that's just going to be radical 3. So therefore the cotangent should be 1 over radical 3, because you got to do the reciprocal. Okay, I think we just have one more to do. Secant is the reciprocal of cosine. So I'm going to ask myself, what is the cosine of negative 5 pi over 4? And then whatever I get for this, I'm just going to take the reciprocal of that. So first I'm going to ask myself, what's the cosine of the reference angle pi over 4? So that's something we have memorized. The cosine of pi over 4 is radical 2 over 2, which is also known as 1 over radical 2. Those are the same. In fact, I usually use 1 over radical 2. Okay, so that's what I'm going to do right now. So this is 1 over radical 2. So the cosine of negative 5 pi over 4 will either be positive 1 over radical 2 or negative 1 over radical 2, depending on the quadrant. So I just need to know what quadrant I'm in. So the reference angle is pi over 4. So I'm going to draw a diagram of pi over 4s. Okay, so negative 5 pi over 4. So I should be counting clockwise. So if I went halfway around, I'm at negative 4 pi over 4. So I'm going to go one more, and that's going to be negative 5 pi over 4. So that's in the second quadrant. Cosine is an x value, and x values are negative to the left of the y-axis, negative in the second quadrant. So this should be negative 1 over radical 2. And so secant should be the reciprocal of this. So this will be negative radical 2. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. click in the green apple to subscribe, or click the yellow apple for the full playlist.